Okay, today we want to present about our final project presentation. My name is Aina Nabila. This is Nur Izaini. This is Farazi and Tevi. This is our project name, Hidden Secret Message Using Steganography Technique, LSB. LSB represent to least significant bit. And this is topic to cover for this presentation. The first one is abstract, limitation of base work, proposed solution, related work, security performance, presentation of system, and the last one is the conclusion for this project. For the abstract is the base work idea. And steganography concept is a hidden data in plain view. For example, in file like a picture, generally the picture look like a normal picture, but it contains hidden data in it. So steganography is useful for sending encrypted message inside another message that might raise suspicion for transmission of the hidden message. If the result suspicion, the goal is defected. And this is using the LSB technique. LSB is another method that being used inside the image steganography, which store the message inside the RGB channel, red, green, blue, of the each pixel by using the least significant bits. And this can make the cover image to the original image that being used without giving a rise to a suspicion that the image has something inside it. So this will ensure the confidentiality of the hidden message. That's why we use LSB. And what we based on the paperwork, it also consists of limitation. What we got from this base work is the result did not consist of the process or how the encryption the data. Therefore, there will be a higher chance for attacker or outsider to track the message. And based on the limitation from the base work, we have proposed a solution to overcome the problem with the latest protocol, method, technique. And we have designed two flowchart. The first one is the proposed solution, and the second one is our proposed solution. And this is the base work, flowchart base work from the paper. We can see that it start and then read the secret message. Okay, we can see that the first step is start and then read the secret message, convert the message to the binary, and then we hiding in blue color the RGB pixel concept, and then for the last step we can produce a stego image. But what we propose for this project, we want the picture can be encrypt the data. So what we do is, from the first step, start and then read the secret message. After that, we convert into a cheaper tag first before we go to another technique, another stage to get the stego image. And for the related work, I pass to my friend Zaini.
Okay, I'm Izaini. For this project, there are several journal we research. The first one is the title and enhancement least significant bit steganography method using midpoint circle approach. This one actually researched by Vikas Verma, Ponam and Rishma Kaula. Okay, based on the researcher, they proposed the technique using the algorithm that already modified, and then in the journal, the researcher explained that in order to hide the message, they proposed the solution that combine the midpoint of circle to choose which pixel to use instead of simply pick up LSB of pixel in a sequence. But there are limitations using this technique. It is because if we using the modified algorithm to secret our to hide our message, the message is still vulnerable to slight image manipulation, cropping and compression. Means that when the user get the message, they can differentiate with the original and the secret one. And then the second literature review based on the study by the study the journal title is a secure through age-based for least significant bit steganography. Okay, based on this researcher, the proposed technique is using Kenny technique, and then they combine with the 4 LSB steganography techniques. They explain that this technique actually utilize age detection based on data hiding techniques, which is the first one to identify the truth of 8 pixel, and then the second one is to double threshold and the process of suppressing noise and with edges using hysteresis tracking. Okay, for this research, the advantage is they can improve the quality of steganography image, and then the second one is to the one of the technique to strong the secure the message high quality steganography image, significantly high PSNR and also reasonable data hiding capacity. Okay, the next paper we research is under title efficient steganography using LSB and encryption technique. Okay, this research proposed by G. Suganti and C.P. Subha. Okay, in this paper, they use the technique which is hide the data in the encrypted image using LSB without the intervention of unauthorized user. Okay, to go more detail to this journal, okay, the data will be hidden in the encrypted image. The hidden data in the binary form is replaced to the LSB position of the encrypted image by binary data. So when the receiver use the secret key to recover the hidden data, in order to get the message, the receiver need to decrypt the message using the secret data. Okay, this approach actually embed information within encrypted image data randomly. Okay, there are advantages using this technique, which is change of detecting the encryption image, then can reduce the security level, then can provide advanced security level of the encrypted image. Okay, the last paper that we researched is the title and adaptive 3-pixel unique steganography algorithm using the least 2 significant bit. Okay, actually this technique is use the combination of LSB and secret LSB. Okay, the technique actually using algorithm with the high of the payload and lower change rate was presented. The features of the technique actually including the unit used from 3 processes, pixel, and the flag regarding from the unit of the second LSB of the pixel. Okay, the advantage using the purpose technique is they can improve the performance of the processing and also improve in terms of security of the secret message. Okay, then we go to the security performance. I pass to my friend Stevie.
Okay, I'm Zuri. So I'll explain about security performance. Okay, so as explained earlier, the quality metrics were PSNR and MSE. PSNR was used to measure the quality of original image with the compressed image, and MSE is to get the average of the set of errors. And to be clear, the higher the PSNR value, the better the quality of the compressed image, the image with the hidden message. And for MSE, the value should be lower. So there were two attacks. One is salt and pepper and Gaussian noise. Okay, this is the image that we chose to test on compressing with the hidden message. So the dimension of the image is 341 times by 338. Okay, so this is the tool that we used. It's actually an application that we have to download to our laptop and our device. That this tool is to determine the PSNR value between two different images, which was the original and the compressed one. So the condition is to be two images should be in same dimension. So this is the histogram for the image, the original image and the compressed image. If you look at the transmission, there will be a little gap in between for compressed image, which is actually to prove that there's no much distortion during the process. Okay, here comes the when the tool we have to add on image 1, which is the original image, and second is image 2, which is the result, which is hidden message, and the value will be showing the most right hand side will be the dimension for the result image, and the middle one will be original image, and that's the PSNR value, which is 51.81, which is to be said as good range of PSNR value for compressing an image with hidden message. So next will be
I will demonstrate the system our group had developed for this kind of technique. Steganography. Okay. Mana gambar? Gambar tu? Gambar tu. Ada tak? Oh, sekejap tu master. Sekejap ada. Ni.
Jauh.
Boleh. Nampak tak tu? Okay. So, ni sistem yang kita cuba bangunkan lah. So, terdapat dua bahagian. Saya kena macam mana? Duduk nampak? Duduk. Okay. Macam ucapan hari raya pula. Okay, dia ada dua section lah, yang mana kita akan, kalau kita tengok pada mouse ni, kita ada encode part, which is kita akan masukkan message ke dalam gambar tu, dan kemudian kita ada second part, which is kita kena decode lah. So kalau kita ada encode saja, macam tak boleh nak buktikan lah benda tu berjaya ke dia masukkan kan. So kita ada part decode, kita akan cuba reveal balik message yang dia masuk tu. Okay, kat sini kita akan masukkan image tu. Kemudian password ni optional, sebab macam kalau sebelum dalam progress 3 tu kita ada mention kita akan simpan contoh daripada total pixel tu, kita akan, the last pixel kita akan bagi untuk dia simpan password lah, in case kalau dia nak retrieve balik di bahagian decode lah. So optional, kalau dia nak letak, sistem akan check lah, kalau ada should be nanti bila decode dia kena dekat last pixel tu dia kena matching dengan code tu lah, kalau tak ada should be tak ada lah. Okay, so kita pakai satu image. Sini kita dah letakkan jenis-jenis image tu, nanti kita akan try. So first image, ini delete kena, delete kan result enough lah, ini delete,
Nak delete?
delete result.
Oh, delete pakai sini.
Okay, so kita just tinggalkan ni 3 image lah yang kita akan test. So kita try first image ni, kita letak password Zurina. Okay, tak apa. So message dia kita letak this message for original 2, original to this second. This message for original to, okay, kita try encode yang kita masukkan lah. So dia akan pilih mana kita nak letak tu, which is kita letak kat dalam folder result ni juga, folder Stegano ni, original to result, save. Okay, dia dah save. Kita akan tengok sekejap. Sorry. Okay, untuk image tadi tu, original ni yang asal, ini original 2 result yang kita baru encode kan tu lah. Nanti sekejap ni, lepas ni saya akan, tak ada tengah buat. Lepas ni kita akan tunjukkan dia punya result lepas kita decode tu lah. So sini kita nak tunjuk dia punya perbezaan dari segi kualiti gambar tu lah. Kalau dia, bila Stegano ni, kita seboleh-bolehnya kita tak nak daripada pandangan mata kasar tu dia ada berbeza lah, supaya kita seboleh-boleh kita nak bagi sama lah, supaya kita tak nak attacker tu boleh cam lah, ni ada something berlaku pada message yang ada kan, pada image yang kedua ni. So kalau kita tengok pada pandangan mata kasar kita, should be kita tak nampak lah perbezaan dia tu. Tapi kita try tengok dari segi detail pula. Okay, itu original punya info, kita masuk, sorry. Okay, apa yang kita boleh tengok sini, sebelah kanan, kiri kita original, yang kiri ni kanan kanan adalah yang result daripada original 2 ni lah. Tengok bawah ni sama, tapi kita tengok dimension dia should be sama lah, 3/338, sini pun 3/338. Okay, sebab kita tak ada ubah, kita tak compress, kita hanya daripada jumlah keseluruhan yang original ni, kita akan gunakan jumlah yang sama, tapi kita masukkan message di beberapa pixel yang akan yang dalam total keseluruhan daripada original lah. So kalau kita nampak kat sini originalnya 70 KB. Bila kita masukkan message ke dalam original tu, dia akan menjadi sedikit besar lah, 168 KB. Okay. So untuk verify yang kedua, kita try decode betul ke ada keluar message tu. Okay, kita jumpa lagi doktor. Choose. Okay, this one kan, result yang kita dah ni image yang dah ada message tu lah. Okay, so kita try masuk password. Macam mana? Tak boleh besarkan ni. Ni besar.
Besar dah ditutup kan.
Tak apa. So kalau kita tengok ni password tadi Zurina kan, tapi kita letak lah 1345, should be dia takkan keluar lah message tu, sebab kita dah setkan dalam gambar original 2 result ni di pixel yang last kali tak nampak pixel yang last kali tu kita letak kita spacekan untuk Zurina kan, so dia akan baca should be Zurina lah untuk membuka image tu. So kita letak 134, dia takkan matching lah. So dia akan keluar. Kenapa dia masih keluar cacing ni, tapi dia meaningless lah, sebab dia akan baca setiap RGB. Contoh tadi kawan saya cakap RGB tu B saja kan, kita letak value dia. So value dia contoh setiap pixel tu 200, 300 ke apa-apa value dia. So dia akan convertkan dalam bentuk binary lah. So tu dia akan keluar bahasa Jawi semua ni. So kalau kita yang special untuk yang original result yang kita betul pakai tu, dia akan pilih yang RGB B dia tu dah ada spesifik nilai lah untuk perkataan this THISMS kan. So dia akan ada nilai lah. So kita try Zurina. So bila kita pakai image tu, dia akan keluar message yang sama macam atas lah. So kita untuk macam verify kali kedua lah, means takut kalau kata kita hard code ke apa kan. So kita try image kedua, kita try decode. Sorry cancel. Kita try decode bahagian ni, image yang kosong, tak ada apa-apa pun. Original 3 ni masih dia standard, tak ada apa-apa, hanya just image saja. So should be so memang tak ada lah, sebab image yang original 3 ni memang kosong, tak ada apa-apa. So kita cuba sekali lagi. Kita try ambil original 3 ni, which is image biasa. Okay, this kita letak lah tu maybe original 3, tambahlah ayat panjang-panjang sikit. Okay. Dia tak nampak apa tu. Okay, kita letak password Zurina 2 maybe. Encode message, dia akan minta space kat mana lah. Kita nak letak result, kita letak nama dia original 3. Original 3 result. Save. Okay. So original 3 result tu kita cuba tengok balik lah. Original result 3. Saya delete ni. Tutup sekejap. Okay, original result 3. Okay, ni kita tengok dari segi pandangan mata kasar tu should be tak ada masalah lah, sama je kan. So kita barangkali orang tu nak boleh detect kata ada something di page, di image ni susah lah, tak ada, kurang lah, bukan tak ada, kurang. So kita tengok daripada dia punya detail pula. Sorry, buka bah lagi. Okay, ni original, this one is the result. So tengok dia punya dimension sama macam saya cakap tadi, kita tak usik dimension, kita cuma add dalam setiap pixel saja. So macam ni 8 KB original dia. Lepas masuk message yang panjang sikit tu, kita akan jadi 57 KB. So dia ada pertambahan sikit lah dari segi size tu. Which is ada something lah di original 3 result ni. So apa something tu kita try buka balik kat sini, original 3 result. Okay, which is dia punya ni Zurina 2. Bismillah. Okay, so kita dapat message yang sama macam yang kita decode tadi lah. Harap projek ni dapat A lah data. Okay, so far itulah yang dapat kita try buat lah dalam sistem ni. Kita berjaya ambil satu image kosong tu, kita try berjaya masukkan message ke dalam gambar tu menggunakan LSB teknik, which is menggunakan the least significant bit lah, which is RGB tu kita kata B lah dulu. So tu je. So conclusion, okay, for the conclusion saya baca, saya explain sikit. So image steganography can be used as alternative lah untuk salah satu cara daripada kriptografi yang ada lah. Macam dia kalau secara negatifnya, dia boleh diguna oleh hacker lah untuk macam letakkan hidden message yang macam kita kata SQL syntax yang boleh harm something lah. So dari segi negatif. Kalau dari segi positifnya, contoh macam dalam military lah, saya kerja dalam military tu, kita nak securely hantar satu message tu tanpa pengetahuan pihak ketiga macam tu. First tu mungkin dia boleh gunakan steganography teknik lah untuk dia paskan benda tu secara senyap lah. And then steganography ni dia offer security approach teknik yang cost efficiency because dia tak memerlukan high appliance untuk melakukan teknik tersebut lah. Dia hanya melibatkan teknik dari segi kita kata coding tu, which is cara kita nak send key tu, itu kita mungkin ada satu kaedah lain lah, kita tak cover dalam scope kita ni, tapi kita just cover dalam scope ni just macam mana kita nak masukkan message tu dalam image tu kan. So mungkin ada satu lagi research lain, mungkin cara kita nak hantar key tu maybe secara secretly in confidentiality way lah. And then it can be done and implement by a large number of software and tools. So benda ni boleh di modify atau alter use daripada offline and online internet. Okay, so semua sini. So thank you. Ni Aina ada cakap apa? Kita selamat Hari Raya Maaf Zahir Batin. Okay, betul. Bagi A betul.